All right, functions quiz review. Here we're going to talk about the first quiz review. I don't know if I'm going to make a second one. I might make a second one. All right, the graph shows the distance a hot air balloon travels over time. Use the graph to answer the following questions. Question A, is the graph a function? And well, based off looking at it, it's yes. And we're doing this based off the vertical line test. Remember the vertical line test, how that works? If you draw a vertical line, you can make it hopefully a little straighter than that, but my microphone got in the way. If you draw a vertical line, straight line, up and down, it's only going to hit the function in one place. There is no place you could draw a vertical line and it would hit the function in just in any more than one spot. So it is a function based off the vertical line test. So we zoom in, we say yes, passes vertical line test. Is a good enough answer. However, you may also state that definition of a function, right? Definition of a function is each input, spelling it wrong, each input has exactly one output. Exactly one output. And the reason why these two things are exactly the same is if we go back to our graph and we look at a vertical line test, for example, here, right? We're saying at the input of 6, remember input values are x values, okay? Number of hours is our input here, whereas our y values are always the output value. So keep that in mind. So each input value, so for example, the input value of 6 has one y value all the way up there at that point, right? And that goes for every input value. An input value at 5 has one output value at 425, and so on. So every input, that's what the vertical line does. The vertical line essentially focuses on one of the input values, like for example, the input value of 4 at this vertical line. And it states that if it only has one point of intersection, it only has one output value. Whereas if the function, for whatever reason, did this, then you would have two output values, right, at that one input value, for in this example, 7, right? That's when it would fail the vertical line test. So these definitions mean the same thing. It passes the vertical line test because each input has exactly one output. All right. What is the x-intercept? What does this represent? Okay, so our x-intercept is where our function is going to intersect the x-axis, right? So these two lines, the x-axis is all the way down here at the bottom. And now clearly our function intersects the x-axis right there. That's where they're joining together. And they join together, of course, at 0. So the x-intercept is 0. X-intercept 0. Now, what does this represent? This means, let me zoom in again on this, okay? All right, so this means, now if we think about it, remember we're talking about a hot air balloon, right? So this means the x-intercept 0 means 0 hours, right? 0 hours. Well, that essentially means that should I say this? It's 0 hours, but its y value happens to also be 0, right? Not 0. 0 miles, right? So essentially what we're talking about here on the x-intercept is that the x-intercept is the time at which the hot air balloon is on the ground, right? If, for example, the intercept was here instead at 5, that would mean after 5 hours, right, or starting at 5 hours, the hot air balloon was on the ground for some reason. Maybe it comes back down and it lands, and then we have an x-intercept here at 10. That would, of course, mean it took 10 hours until the hot air balloon was on the ground. So the x-intercept is at 0, indicating that the hot air balloon is on the ground at time 0, or the hot air balloon is on the ground at the beginning. This means hot air balloon on ground at beginning. Okay. All right. I don't know how to spell words. What is the y-intercept? Okay, so the y-intercept coincidentally, okay, coincidincally, happens to also be right here at 0 because Well, now talking about the y-intercept, we're talking about the same function, this function here, where it intersects the y-axis rather than the x-axis. And of course, it's down here at the bottom again. That's where those two lines converge, right? So this y-intercept happens to be on the y-axis all the way at 0 on the y-axis. So y-axis is this one, right? They're intersecting, whatever. Y-axis is at 0. So y-intercept is 0 in this case as well. This is the height of our, this is the height of the balloon, okay, at the beginning. All right. So essentially, the y-intercept being 0 means that at the very start, the hot air balloon is beginning on the ground at 0, or not on the ground, but 0 miles away. It's not the height, it's the distance, I should say. This is the distance of the balloon at the beginning. So obviously, at the beginning, you're at the start. You're 0 miles away from where you started because you're at the start. That's hence the beginning. But maybe for whatever reason, let's just talk hypothetical for a second here. Let's say it starts right here, right? Let's say the y-intercept was there and our function looks like that instead, and we can just ignore this one, right? Just speaking hypothetically so you get a better understanding of the y-intercept. In this case, the y-intercept would be 255. What that would indicate to us is that at the start, we're already 255 miles away from, let's consider home, right? Or base or the airport or something, wherever this hot air balloon left or supposed to be, right? It would indicate that it's 255 miles already away from wherever it was supposed to be. So just kind of keep that in mind. This is the distance where it starts from. If it started 425 miles away from its home, then it started 425 miles away from its home. But in this case, it's starting at home. You can kind of say that, right? It's starting at 0 miles away from its home, so it's starting at its home. True or false? The miles flown represents the input values. Now, input values, remember, are the x values. Now, x values represent number of hours, not the miles flown, because the miles flown is our y-axis, which is our output values. So this would be false. The miles flown really represents the output values, whereas the number of hours would represent the input values. All right, and then true or false? The number of hours the balloon flies relates to the miles it travels. So think of it like this, right? Hours relates to miles, right? So this is x to y. This is kind of how it's being phrased. You will see this on your test as well, so kind of make sure you kind of sort of draw it out like this. Hours relates to miles, meaning hours is x, miles is y. And is that what the graph is representing? Well, yes, because hours represent our x values, our input values, and the number of miles represents our y values, the output values. So indeed, this is correct. This is true. Now, if you're wondering when it would be false, it'd be false if it said this the other way around. If it said miles relates to hours, because then it's sort of indicating that it's sort of indicating to us that miles is the input and hours is the output, which is not the case. So if it were kind of reversed, I would say it would be false. All right, so number 2, use the graph to answer the following questions. Okay, so our domain. Now remember, for domain on number 2, we are focused on left and right. It's very important you understand that all you're thinking about is left to right. We are not thinking about how far up the graph goes. We do not care how far up it goes or how far down it goes. All we care about is how far left and how far right. So ignore things like the altitudes, okay, or the lowest point. Don't focus on how high or up it is, right? How high it is or how down it is, how low it is. Just focus on how far left and right this goes, because domain refers to the x-axis, and you'll notice the x-axis goes left and right. So start with that. Now, the furthest left this graph goes would be here, right? Let me zoom in on this a little bit, right there. That's the furthest left that this graph goes. Okay. You kind of get the idea, right? All right. That's the furthest left that this graph goes. And you'll notice, as far as the x-axis is concerned, that's about negative 2.5. Okay. Hold on a second. My pen's doing the thing again where it's deciding not to work properly. So, just let me see if I can get it to work. If I can't get it to work, and I'll pause this and start a second video. I'll probably just start a second video because it's a little laggy. All right, so I'll come back to this problem. I'll answer 2 and 3 in a separate one. I'll see you guys there. I'll link it to this video as well, so you guys can watch it. But I can't work with my pen. Is a slight delay. So just to give you a heads up. Okay, see, I'm putting my pen on the screen now, and then it just started writing. So it's weird. But anyway, I'll see you guys in the second video covering question 2 with both these graphs. All right.